Welcome to Nano Zorro, the podcast of Tech Zorro, presented by Juditova. Engage with your ears about engineering, development and inventions, as well as interviews with experts and hobbyists. You will learn to make better decisions with your designs, programs and manufactures in order to optimize and develop your products and services, or just for fun. You can find the show notes from the episode, the transcription, and much more by entering to techzorro.com/podcast. And now your host, engineer, crafter, and tech enthusiast, Juditova.
If you like this podcast or the blog, and you do want to support the show, go to our site in Patreon to contribute with a monthly donation. You will have early access to its episodes, you will be recognized as a Patreon in the website, among other benefits. There are several tiers available, starting from $3, or if you feel altruist or generous, there are superior tiers. You just have to go to the website techzorro.com/Patreon. In the show notes or description, you will find the link. We will kindly appreciate all contribution. All right then, let's start with today's episode. Welcome to a new episode of Nano Zorro, the podcast about electronics, networking, and programming. It is the episode number 7, and today we're going to talk about layers of Internet Protocol. Wow, it is episode 7 already? Amazing. Okay, so what is exactly the Internet Protocol? Which protocols are used in Internet? Well, in order to make computers to communicate, we cannot just plug some network cables between them and expect them to be recognized and work right away. Right? Right? Well, no, we can't. But just as humans, computers need a group of rules and procedures on how to communicate called protocols. For example, let's say humans, before engaging in a conversation, they say, hi, right? This is a basic human protocol. So machines need them as well. This episode talks about the Internet Protocol layers explanation, or also sometimes referred as TCP//IP, and what is this all about? This is not an in-depth analysis. This is just informative because we could need at least 1 or 2 episodes per layer to explain everything that it does. So it's just informative. Do you want to know how the internet is built on? What is the Internet Protocol and how does it work? Keep listening and learn a few of the steps that your computer and cell phone requires to do everything to reach out the world. Let's go. What are the Internet Protocol layers? It's a group of communication rules and protocols used to communicate between computer, servers, and many other devices. It's widely used in Internet, as the name suggests. Its role is to provide end-to-end communication between devices. It specifies how data should be distributed, addressed, transmitted, packetized, routed, sent, and received. Sounds complicated, isn't it? But luckily, we could divide this complexity into layers, abstract layers, by the way, and realize how it works. So network parts of TCP/IP. A network consists in many pieces. Some of them are protocols, routers, hosts, links, applications, hardware, algorithms. But not all of them work in the same way, are in the same hierarchy, or perform the same tasks. Let's see how the Internet Protocol is organized. Communication of Internet Protocol layers. Okay, Internet Protocol is classified in, as I said before, in abstract layers that are in charge of organize, verify, and route the traffic, both incoming and outgoing. From the bottom, the physical layer, to the top, application layer, TCP/IP is organized in this order. The top layer, the application layer. It supports network applications. We're going to see more examples, but it could be, for example, web browsing, file transfers, email, and so on. Okay, number 2, the transport layer, just below the application layer. It processes and manages all related to the transfer of information. We're going to see a difference between the other layers because this may not be so easily to understand in the beginning. But the transport layer essentially is the one that manages how that packets should be transferred from one place to another and what rules should be considered in order to make a quick transfer of a packet, or perhaps it should be a reliable transfer of packets. So you should send many packets and check afterwards if it has been received successfully. Number 3, network. It manages datagrams that crosses the networks from source to destination. In other words, it communicates in the location, the logical direction or address that a computer server and router has. So it assures that the packets goes through a certain route and it actually managed to arrive to the destination. Number 4, the link layer. It serves as passage to connect the neighboring elements in the network. And number 5, the physical layer. This is at the bottom of all the layers. All related to the analogic phenomenon, physical nature, I will say, that actually carries the information from one place to another. It is, for example, via copper cable or satellite wireless networks. It is fiber optics, light, and everything in this category goes here in the physical layer. Yes, I understand. It could be a little difficult to understand what is exactly this organization of layers. But don't worry, I have prepared an airplane analogy that I took respectfully from a book where I actually learned about computer networking. So let's see how we could do this work. Okay, so let's review the steps required to go in a flight with an airplane from place A to place B. Okay, you have to purchase the ticket, right? Then you have to check in your baggage in the counter. Afterwards, you have to go to the gates and to load yourself into the airplane, to step in the airplane. Then the airplane has to go to the runway in order to take off. And finally, the airplane has to take the route into the destination. Well, these routes may take some time. They have to take different routes and so on, right? And, well, what do you have to do when you arrive? Well, you land. well, you spot the airplane, right? The airport. Then you have to land in the runway, right? The airplane has to reach the gate to unload everything, the passengers, the baggage, everything. Then the baggage has to be claimed somewhere in the airport. And then sometimes you have to use the ticket to claim the baggage or, well, get out of the airplane. Right? Understood? It is an everyday example, and we are now going to see how this concept can be translated to package instead of baggage. Notice that everything that I just said is reversible, I will say. You have to do one procedure and then the opposite procedure in order to finish all this process. So how does exactly this is comparable to computer networking or the internet layers of communication? Okay, let's see. First, let's imagine yourself a stack on the left when you have to take off in location A, and another stack on location B where you want to arrive. So every procedure that you did from purchase the ticket to step in the airplane is considered the layers that you have to do in order to take off. And on the opposite equivalent, you have to do to step out of the airplane in the stack B of the destination B. So each layer symbolizes a different procedure. The application layer, as I mentioned before, let's say the email, the file transfer protocol, is exactly when you buy or purchase a ticket. The transport layer is in charge of the baggage to see where it has to be loaded and how this should be sent. The network layer is associated with the gate of the airport. The link layer is associated with the takeoff or landing, respectively. And the physical layer is associated with the airplane routing itself. So how exactly the airplane goes to that place. Each layer performs a specific service, as I'm going to explain later in this episode. And each one of them attaches, like I will say, a header or indication that corresponds to this layer, to the message sent by the application. So let's say a message has 10 blocks of information, and each layer adds one block for indication about how it should be handled. For example, the transport layer adds one block called segment. On the network layer, a datagram, as is called this block, is added. We have already 2. The link layer adds another block to this 10 blocks message, which is called a frame. And we already have a message of 10 blocks, and we have 4 blocks that carries information about the different layers. The physical layer does not add any block to this analogy. Now, let's see some of the layers that composes this protocol. So, let's talk about the physical layer. Usually deployed in coaxial, twisted pair, fiber optics, or wireless radio waves. It refers to the physical media where the signals are going to be carried. The other layers of TCP/IP protocol work exactly despite being carried by a different physical nature. The link layer. After the physical layer, a computer network has to realize the quote-unquote existence of nodes or paths that interconnect many other computers, servers, and of course the switches that interconnect them. This layer is all about linking the communication path. The link layer encapsulates a datagram by adding a frame header to it. as I mentioned before, this block message that attaches to the 10 block message is exactly this. Afterwards, it has the responsibility to transfer it from one node to the next node. Some of the services to the communication is flow control and determine if the connection is suitable for half duplex or full duplex. It also checks if there is parity in the last bit, the parity bit, to check if there was any mistakes or errors in the communication in that specific packet. Switches and access points are used to communicate between devices in this layer. In this layer, we have the MAC address. It stands for Media Access Control. It is used in the link layer to locate the nodes for communication. It has a 48-bit address in hexadecimal numbers, such as, for example, 58-53-D7- etc. In total, 12 alphanumeric characters. The allocation of the addresses are managed by the Institution of Electric and Electronic Engineers, also called IEEE for short, and it is assigned to every manufacturer. It is portable since the network adapter can move from network to network. Do not confuse it with the IP address. Ethernet and Wi-Fi are different network adapters with different MAC addresses. Both can be connected to the same computer, yet connected to different networks. I will leave a link in the show notes of this episode so you can see where it should be connected in practical situations, either Ethernet or Wi-Fi. Now, the network layer. Beyond recognizing nodes in the network layer organizes the device with a logical assignation, which are the IP addresses. The device that communicates different networks is called router. Routing determines the path or route that package should take from source to destination in that networks in the reach of the routing device. When a device receives a datagram, it uploads to the transport layer if no error was detected. If it sends to the network, the segment gets encapsulated into a datagram. So we already referred to an AP address, but what is it? It manages the addressing conventions, the format that the header and of the datagram should have, how packets are handled, and much more. The header includes information such as IP address from source to destination, checksum, time to live, IP version, length, etc. IPv4 is a 32-bit address, usually presented in 4 pieces with the numerical characters, and it looks like this. For example, 192.168.100.60. This IP version is commonly found in local area networks and in many internet providers. Eventually, it will be replaced with IPv6, which has more addressing capability with its 128-bit address. Typically, a IPv6 address will look something very long. I'm not going to pronounce it all. And it is composed by hexadecimal characters, on the contrary of IPv4 that has just numbers. Now let's talk about routing protocols. First, let's talk about RIP. No, it does not mean rest in peace. It means Routing Information Protocol. It measures the number of hops from router to router in order to get to the destination. Devices exchange routing information every 30 seconds or so. It is often referred to it as routing by rumor, and it has flaws with the spread of information. RIP could be summed up as good news travel fast, bad news travel slow, and is not recommended for high performance networks. OSPF. It stands for Open Shortest Path First, and is this algorithm of routing. It is based on the excuse me if I don't pronounce this well, Dijkstra algorithm. Let me try again. Dijkstra's algorithm. And I will leave a link to the blog post so you can see this in more detail. It uses the technique to flood, which means send discovery packages by all the gates, all the ports of the router except from which the packet came from, to all the network and available nodes to draw, I will say, like a topology map. Contrary to RIP, it measures the cost path instead of hops, and OSPF messages are authenticated to leave intruders out. And finally, let's talk about one more protocol, DHCP. It stands for Dynamic Host Configuration Protocol, and it provides an IP address to a device recently connected to the network. It is intended to work as a plug-and-play feature. If this feature will not exist, then a network manager should assign manually each IP to each computer or device that connects to a network. Note that this may be seen as a tedious task, but on the other hand, it could increase the security in the network. The transportation layer. Once networks have been established, how should packages arrive to the destination in a speedy, efficient, and reliable way? Should we send them in order or as they become available? The transportation layer is in charge to manage the package sent and received from the end of the communication. In the TCP/IP protocol, two protocols are commonly used to exchange information. It uses segments to carry information related to this process, such as ports from the source and destination. The first protocol is the UDP. It stands for User Datagram Protocol. It does not establish a connection between the host and client, or source and destination. When an application does not require a 100% reliable information communication, UDP may be a good option. Some packets may be lost or delivered out of order. Such applications will be, for example, a Zoom call, a movie streaming service, a GPS location service, or an online video game where 1 out of 20 or 2,000 packets could be lost and the application will still work properly. Some of these advantages are, first of all, no connection required. It starts right away. 2. It is simpler. 3. Manages a smaller header size. And 4. No congestion control. Now, sometimes I was lost in trying to understand this principle, but it is something like this. Can you tolerate a loss of, could be 1%, 10% of package loss in a video call, for example? Or do you need exactly all packages to be sent from one place to another? Well, if you are just chatting with a friend, you can tolerate, for example, a loss of certain packages, let's say background noise. Who cares if the background noise gets lost? And if, let's say, too many packages are lost, let's say 50% of packages lost, then the quality of the call then has to be lowered so the less packages are being lost. It is because real-time communications require this protocol to work properly. Otherwise, Not possible. Simply, it wouldn't be possible. Now, the next protocol is the TCP. It stands for Transmission Control Protocol. TCP ensures that a file is delivered to and received by other device in a reliable way. It features 1. Flow control. It doesn't send more information than it is received. Number 2. Segment structure. Timeout in delayed packages, acknowledgement that it has been received, etc. Number 3. Congestion control. Sender is throttled if its network is overloaded or unresponsive. Number 4. Reliability. Files and information are identical on both sides. Number 5. Connection management. Host and client have handshaked before even sending the first package. There is a feature in this frame called the checksum, which function is to check if there is any errors in the received package. If there is a mistake, then the layer won't upload the information into the application layer. If it will upload it, then with mistakes, then it will be no reliable transfer. The application layer. All related to the programs on the operating system or a device that require to communicate outside its device. The application layer from the Internet Protocol layers are the seeable or viewable from the user or direct client screen. It is composed by programs such as, as mentioned before, web browsing, email, remote login, P2P file sharing, real-time conferencing, audio calls, email, and so on. First, let's check this, perhaps one of the most iconic protocols in this layer, is the HTTP protocol. It stands for Hypertext Transfer Protocol. It is the foundation on how websites work all around the world. It consists in objects in which a client, like a user, interacts with a website, such as HTML code and files, audio and video, etc. Every object has its addressable URL, such as, for example, www.techzorro.com/content/picture.jpg. So, techzorro.com is the name of the host and /content/picture.jpg is the name of the path. The default port for HTTP is 80. Now we have FTP. It stands for File Transfer Protocol. It establishes a set of rules in order to pass a file, or several of them, from a computer host to a computer client. One important feature is its reliability. The file must not arrive to the client with corrupted, incomplete, or false data. In such files can be pictures, PDFs, binary or system files, etc. The default port for FTP is 21 for control connection and 20 for data connection. Both of them uses TCP from the transport layer. Now let's talk about email, or SMTP, which stands for Simple Mail Transfer Protocol. Electronic mail uses different protocols such as SMTP, which is in charge of the delivery and storage in the receiver's server. Other protocols involve the retrieval from the server, such as POP, IMAP, or even HTTP. SMTP involves user agents, mail servers, and the protocol itself. First, the user agent. It is the mail receiver app, such as Thunderbird or Outlook. 2. Mail servers. The mailbox with all the content in the server is ready to send to the user. And finally, SMTP. It transfers from the receiving server to the sending server. It uses TCP to transfer emails from client to server using port 25. DNS. It stands for Domain Name System. Like humans, computers uses name and identifiers. It is a gigantic database of name servers with their corresponding server distributed worldwide. For example, humans have ID cards and names. Servers and computers have IP addresses. For example, when you type www.wikipedia.org in your web browser, it searched in the closest DNS server and it returned its corresponding IP address to reach it. Computers do not understand names of servers. One of the benefits of not centralizing DNS are if one server shuts down or breaks down, the other DNS servers are still operational. It handles traffic better since it scales better. Shorter distance to travel, quicker in response. And finally, it eases maintenance. And the final protocol that we are going to listen today is SSH. It stands for Secure Shell Protocol. It is a crypted protocol for communication with services from a client to a host. Typically, it is used for remote login in a computer in the same local area network, but often beyond it, as well as in the command line of execution. First, the IP address and the port number, if not the default one. It has to be written down, and then the user and password of the host computer or server. If the connection is established, then remote access to the command line or command prompt of the target computer is given. Well, that's all for today. We have seen the internet protocol layers and most of the important protocols involved. A general description about each layer is given and the role it performs. Furthermore, some layers of each layer were explained and, in few sentences, to have an idea about different services they provide. So how about you? Did you learn something useful today? I will leave a link in the description of this episode so you can check the blog afterwards. I hope you have enjoyed this episode so far and that you have learned something useful for your next craft or project. Before you go, I just need a favor from you. Go to the application where you are hearing this right now and leave us your honest review and a like or a rating from 1 to 5 stars. This way, more people will be able to find this episode and enjoy it as well. It will mean so much. Juditova says goodbye. Until next time.
That's all for this episode. We hope that you found a moment of enlightenment and that you have enhanced your skills or cleared some doubts. For more interviews, tutorials, blueprints, and advice, go to the website techzorro.com/podcast. Juditova expects you in the next episode. Don't forget to subscribe. Happy crafting!